Now, if you were paying attention, you'll know that for synthetic division, I cannot divide by 2x minus 3 because I have to have a 1 as the coefficient. Well, one way to look at this is if I take 2x minus 3 and I do something very strange, I factor a 2 out. So 2 times x is 2x, subtract 2 times 3 halves, right? Because if the 2's go away, I get the 3. 3 halves. So I could say, bringing back those 2 for the moment, that x minus 3 halves is a factor. And so then, I'm going to put 3 halves here. And here are the coefficients. And I'll bring down, then I'll multiply. 3 over 2 times 2, the 2's are gone, leaving us with 3. And I add, and I get 2. 3 times 3 halves times 2 again, the 2's are gone, leaving me with 3. Add, and I get negative 24. 3 halves times negative 24 I can reduce, and 3 times negative 12 is negative 36. Add, and I get 0. So, our x minus 3 halves is here, and our quotient is x squared, because the original was x cubed. I have 2x squared plus 2x minus 24, and the 0 must be the remainder. So then our remaining coefficient 2x squared plus 2x minus 24, you're right, I had to make a correction. And then we see that each of these has a common factor of 2. We take it out and we're left with x squared plus x minus 12, right? And you might have been wondering where that 2 went off to that I yanked out a while ago. Well, there it is. If I put it back here, don't I get 2x minus 3? And then this x squared plus x minus 12 factors to x plus 4, and x minus 3, let's check. X times x, x squared, 4 times negative 3, negative 12, 4x, and negative 3x. Sure enough, the middle term matches. Now what's nice about synthetic division is if I have to do it a lot, and it's kind of quick, it's not so bad. So here I'm going to actually do it twice. So we take the x minus 2, there's the 2 is what we're subtracting, and here is where the zeros come into play. We're missing a third degree term, and we're missing an x term. That's why there were zeros in these two positions. We still have the 1, we still have the negative 13, and we still have the 36 for the alternating terms. Then we bring down, multiply, add, multiply, add, multiply, add, and then multiply, and look at that. We add and we get 0 again. So then, for the moment, don't we have x minus 2 times x cubed plus 2x squared minus 9x minus 18? Well, we are told that x plus 2 works. So here's what I'm going to do. I'm going to factor just this part. I'm going to keep the x minus 2, and I'm going to take this part that remains as my new dividend, the thing that I'm dividing. And this time, I have to use, because this is x plus 2, it's really x subtracting a negative 2, so the negative 2 goes here now. And I bring down, multiply, add, multiplying here, I get 0, add, I get negative 9, multiply here, I get 18, add, I get 0. So this was third degree. I'm dividing by a first degree. So the quotient must be second degree. And there's a 0 term there. That's the missing term. And so I have x squared minus 9 from the division of x plus 2. Then, of course, I hope you see it, that we can factor the x squared minus 9 into x plus 3, x minus 3, one of the easier kinds of factoring. So real quick, I hope you see from the beginning, if I plug in 0 for x, I'm going to get 36 left. Plug in 0 for x, I'll get 36. And so obviously there's not 36 boxes, so I'm just going to mark this clearly as 36. Ignore the boxes for the y direction. And then we have x minus 2, x plus 2, x plus 3, x minus 3 for the factors. And they indicate to us that the x-intercepts are negative 3, negative 2, 2, and 3. The first term is x to the 4th. The leading coefficient is positive. The right hand goes up. The degree is even. The left is the same as the right hand. That's why it goes up. So if I start with up, go down through the 3, come back up through the 2, go up to the 36, come back down to the negative 2, come back up through the negative 3, and the left hand goes up as well. The factor theorem. We saw that if x minus 7 is a factor, if I plug in 7, I'm going to get 0. If 2x minus 3 is a factor, if I plug in 3/2, I'm going to get 0. If x minus 2 is a factor, if I plug in 2, I'll get 0. And if x plus 2 is a factor, and I plug in negative 2, I'll get 0. So if something is a factor, meaning it goes in evenly, then if the remainder is 0, or if the plug-in answer is 0, then x minus a is a factor of the polynomial. So we have our original polynomial. We want to know if any of these are factors. So again, there's that opposite kind of idea. If x is negative 2, if x is negative 8, if x is 8, if x is negative 4. So I plug in those values, and I'm careful about parentheses and order of operations. This one gives me 0, this one gives me 0, This one gives me 0, so these are all factors. But the question, which one is not? Well, when I plugged in the -8, and you go ahead and do what this is, but here's what I saw. As this is a -500, this is -100, so we're already at -600. I'm going to come back only 300 and then go negative some more. There's no way it's going to be a 0. I don't have to worry about what it is exactly. Now here's a strange question. We have a problem with another variable k. And they want to know if x minus 1 is a factor of this original polynomial, what does k have to be? Well, let's see. If x minus 1 is a factor, f of 1, plugging in 1, should give me 0. So if I plug in 1 for x, plug in 1 for x, and leave k alone, just let it be k. And then I work out everything else with k being left k. And then I go, oh, I have an equation where there's only k because x became a number. And so I solve for k, and k is -8. And the question was, what was the value of k? It didn't ask me for the value of x. In fact, they gave me the value for x. It's 1. I found k is -8, and we're done.